Good morning, grade 10 students. In division of polynomials, the quotient and the remainder can be obtained by long division. However, when the divisor is in the form of x minus a or mx minus n or simply binomial, there is a simpler method to find the remainder. Consider when a polynomial f of x is divided by x minus a using division algorithm. F of x times the quantity of x minus a times q of x plus r, where q of x here and r are the quotient and remainder respectively. Now by substituting class x equals a into algorithm form, we have f of a. So substitute the value of a, the given algorithm, it will be a minus a times q of x plus r. Now we all know that a minus a is equal to 0 times q of a, then copy q of a plus r. Now multiplying 0 times q of a will give us 0 plus r. Then 0 plus r is equal to r. And this gives us now the remainder theorem. Remainder theorem states that when a polynomial f of x is divided by x minus a, the remainder is equal to f of a. Or in other words, class, without doing the long division or synthetic division, you can identify right away the remainder of a polynomial, of division of polynomials, by using this theorem. Now, the corollary statement of remainder theorem is when a polynomial f of x is divided by mx minus n, then the remainder is equal to f of n over m. Now, this only applies to divisor binomial if we do have leading coefficient, which means if you do have leading coefficient in your divisor, the constant or the f of x must be fraction. Okay, so let's use this remainder theorem in this example. Find the remainder when 2x cubed plus 5x squared plus x minus 2 is divided by the following. So let's start first with x plus 2. Here we have given 2x cubed plus 5x squared plus x minus 2. Let's use remainder theorem to identify what must be its remainder when we divide the given f of x by the first given, which is x plus 2. The rule of using synthetic division, you must get the opposite of the constant term of the divisor. So in this case, it must be negative 2 or f of negative 2. So using the values of f of negative 2 here, you'll substitute negative 2 to all the value to all x's in the given f of x. So this will be 2 times negative 2 to the third power plus 5 times negative 2 to the second power plus negative 2 minus 2. So we'll evaluate first negative 2 to the third power, and that becomes negative 8. Then multiply it to 2, we'll have negative 16. Then 5 times the quantity of negative 2 to the second power. Of course, you will deal first with negative 2 to the second power, and that becomes positive 4 times 5. It is now positive 20. Then minus 2 minus 2. So having this, negative 16 plus 20 will be positive 4, minus 2 is 2, minus 2 and minus 2 is 0. So your f of negative 2 here is 0, which means if we're going to divide 2x cubed plus 5x squared plus x minus 2 by x plus 2, we'll have 0 remainder. Let's have the second problem. We're going to divide 2x cubed, the same given, 2x cubed plus 5x squared plus x minus 2 by 2x minus 1. And let's use remainder theorem. What would be the remainder if we divide given f of x by 2x minus 1? Now, what's unique with this problem, class? We have now leading coefficient of x. So we're going to use the corollary statement of remainder theorem, which is f of n over m. Which means we're going to divide both terms by the leading coefficient for us to have a 1 as leading coefficient, which means we're going to divide 2x minus 1 by 2. So this will be 2x minus 1 divided by 2 will cancel out the 2 in 2x, and then 1, negative 1 divided by 2 will have negative 1 half. So this will be x minus 1 half, which means we're going to get the positive now of the coefficient of the constant, which is negative 1 half. With this, using f of 1 half, we'll substitute um, 1 half to all x's in the given f of x. So this will be 2 times 1 half to the third power plus 5 times 1 half to the second power plus 1 half minus 2. So evaluating this, this will have 2 times 1 half to the third power is 1/8 plus 5 times 1 half to the second power is 1/4. Then copy 1 half minus 2. So multiplying 2 by 1/8 will be 1/4. And then 5 times 1/4 is 5/4. Then copy again 1 half minus 2. So adding 1/4 to 5/4 will have 6/4 or 3 halves plus 1 half is 4/2, and that becomes 2. So 2 minus 2 here is 0, which means f of 1 half is equal to 0, meaning to say, if we will divide 2x cubed plus 5x squared plus x minus 2 to 2x minus 1, there will be no remainder. Let's have another example. When 2x cubed minus 3x squared minus x plus p is divided by 2x plus 3, the remainder is negative 4. Find the value of p. So with this, we're going to use remainder theorem to identify the value of p given the divisor, which is 2x plus 3. Now notice here that divisor has coefficient of x that is not equal to 1. So do the same thing. You have to divide this by the leading coefficient to cancel or to make it 1. So 2x plus 3 will divide both terms by 2. So cancel out 2, we'll have x plus 3 halves, which means we're going to use here negative 3 halves as your f of x. So having this, it will be f of negative 3 halves equals 2x cubed minus 3x squared minus x plus p. So we'll substitute negative 3 halves in all x's. So substituting again negative 3 halves to all x's, this will be 2 times negative 3 halves raised to the third power minus 3 times negative 3 halves to the second power minus negative 3 halves plus p. So evaluating the exponents, this will be 2 times negative 3 halves raised to the third power will be negative 27 over 8. Then minus 3 times negative 3 to the second power, negative 3 halves to the second power will be positive 9 over 4. The negative of negative 3 halves will be positive 3 halves, then copy plus p, which will be equated to negative 4 since the given remainder in the problem is negative 4. So this will be equals sign. Now, evaluating the process or the operations, we can cancel, multiplying 2 times negative 27 over 8. This will be cancelled, the 8 will be cancelled, it will be 4. Then the 2 will be 1 or cancel out. So this will be 2 times negative 27 over 8 will be negative 27 over 4. Then 3 times 9 over 4 will be 27 over 4 plus 3 halves plus p. So combine negative 27 minus negative 27 over 4. This will be negative 54 over 4 plus 3 halves plus p equals again to negative 4. Now, combining negative 54 over 4 to 3 halves, it will be negative 48 over 4 plus p equals 4. Now, negative 48 over 4 can be written as negative 12. So this will be negative 12 plus p is equal to negative 4. So transpose negative 12 to the other side. This will be negative 4 plus 12 is equal to p. So combine negative 4 to 12, it will be now positive 8. So that is now the value of p.